Log on, tune in, find out. Another good idea from Cambridge.
So without further ado, I'm going to ask first Sir John Houghton to come and speak about a sustainable climate. He's exceedingly well qualified to do that because he was chairman of the IPCC, the Intergovernmental Panel on Climate Change, for many years. He shared in the Nobel Peace Prize, which was given for the IPCC just recently, and he has a very distinguished list of achievements to his name, which I won't go through now because we'll lose most of his talk time. So let me hand over to Sir John Houghton to speak about a sustainable climate.
Thank you, Rob. It's a great pleasure to be here to talk about this subject of unsustainability. Let me begin by following Butts the same sort of remarks that Bob has just been saying. That supposing you're in a spaceship and there's 6 of you, and you're going to a distant planet, and it's going to take months to get there. How are you going to survive on the journey? You're going to have to, you've got energy from the sun, so that provides the energy you need, but what about food and what about everything else? You'll need a biosphere module to grow your food. You'll have to recycle 100% of your waste. You will have to have means of mending things that go wrong. And if for any reason you are unsustainable, then what happens then? You are extinguished. You don't live anymore. That's the end, and your spaceship will carry on into oblivion somewhere in the universe. Now, we all live on a spaceship. Something going through space, which Bob's already introduced to us. There are not 6 of us, there are 6.5 billion of us on spaceship Earth. In 1966, Professor Kenneth Boulding, who is a distinguished American economist at the time, wrote a paper which contrasted a spaceship economy, because he already knew a bit about spaceships, even though the first Sputnik had yet to go up, and what he called a cowboy economy. The contrast to you is very stark. We live at the moment in a cowboy economy, which is unsustainable. We need to move to a spaceship economy, which is sustainable. Just another thing about sustainability is a word that's commonly used without much clear definition. The simplest definition I know is just 3 statements. It's not cheating on our children, not cheating on our neighbours, and not cheating on the rest of creation. And just before I get on to the climate change issue, just to put that in context, there are many things that are unsustainable in our world. Just a quick list of them there: poverty, water, energy, the way it's distributed, habitat and species loss, land use, loss of forest and of soil, and the list could go. What is that driven by? Some of the things that are talked about later today: the growth of population, overconsumption, and the greed that sustains that, unsustainable trade, and human-induced climate change, which I shall now get into right away. And just start by very quickly talking about the science of that. The basic science of the greenhouse effect has been known for 200 years, over 200 years. So sunlight comes and warms the Earth's surface. That energy coming in is balanced by infrared radiation going out, much of which is absorbed on the way out by greenhouse gases, carbon dioxide, methane, and nitrous oxides, and so on. They act as a blanket over the Earth's surface, just like a blanket in bed. It keeps you warmer than you would otherwise be. A greenhouse operates the same way, in that the glass in the greenhouse lets in the sunlight, blocks the infrared, and that's one reason why a greenhouse is warm. If we look at the main greenhouse gases, other than water vapour, water vapour is a greenhouse gas, but it is not increasing because of direct human action. The gases carbon dioxide, methane and N2O, they have been rising very rapidly compared with what happened before 1800 or so during the last 200 years. And that just shows you that they are rising very rapidly, and in the concentration of carbon dioxide, for instance, will hit the ceiling really quite soon if we do nothing about it. So what's that doing to the Earth? It's increasing the temperature. It's increased the temperature over the 20th century. I can give you more details of that. But perhaps just to mention that some people say, oh, but it was increasing to the year 2000. Since 2000, it's not increased at all, which is interesting. There's been very little increase in the global average temperature since 2000. The global average temperature has remained rather steady. But there is still the upward trend, because there's a lot of year-to-year variation. If you take the 7 years before 2000 and the 7 years since 2000, there is an increase of 0.1 of a degree C between the averages of those two periods, and that matches the average trend since about 1970 or 1980 very precisely. So it is the average which we're talking about, and not the variations from year to year, which are large, because climate is a variable thing and very influenced by things like the El Niño effect and so on. This century, the temperature is likely to go up if we carry on burning fossil fuels at the rate we're doing at the moment, or something like it. It's going to go up by up to 2 or 3 or 4 degrees above the present average temperature. That may not sound a great deal, because I guess the temperature in this lecture theatre has gone up since we came into it by about that much. But this is a global average. And that change in the global average is enormous. The difference in temperature between the middle of an ice age and the warm periods in between, in terms of the global average, is 5 or 6 degrees. So 2 or 3 degrees by the end of this century is equivalent to about half an ice age in climate change terms. And that's going to happen this century, in 100 years, whereas changes in the past tended to happen over many thousands of years. And it is that later change which is going to be very hard for humans and for ecosystems to adapt to, and that's the problem of climate change. Now, talking about global average, of course, it doesn't tell us very much about what's really going on. What are the main impacts? So let me just list them for you very quickly. More intense heat waves, sea level rise, and a more intense hydrological cycle are the most important things we're going to have to grapple with. Heat waves. 2003, Central Europe, there was a heat wave quite outside the range of natural variability. So much outside the range of natural variability. There you see those blue lines, and the average temperatures in central Switzerland for June, for a 3-month period, June, July and August, which occurred from 1864 until 2002. The ice form was the Gaussian distribution. 2003, 5 standard deviations away from the norm. 20, 30 or 40,000 people died, depending which statistics you believe, but a lot of people died prematurely because of that heat wave. So when people like me started to talk about climate change being a weapon of mass destruction, that wasn't just because I was getting old and hyping things up in a way I hadn't used to, but it was because we had real evidence that climate change really was affecting humans in a very big way. And this has been carefully analysed, and they show that by 2050 it's likely to be an average summer in Europe. By 2100 it could be a cool summer in Europe. And that's not just Europe. And that same year, thousands of people died in India because the temperature was rising for 20, 30 days in a row to temperatures of like 46, 47, 48 Celsius in the middle of India, where they're used to heat in a big way, but they weren't used to heat so persistent. So lots of people died there too. Sea level rise. Cambridge will be fairly close to sea level as the sea starts to rise, and places which billions will have to be spent on in East Anglia to do something about it. But we have the money and we could do something about it. But go to Bangladesh. 10 million people live below the 1 metre contour. Where are those people going to go? Sea level is likely to rise because the ocean's warming up. This is not in the first place because of melting ice caps, so though melting ice caps will add to it, the sea level is going to rise between half a metre and a metre by combining those, what we know about those two regimes. 25 million people in southern China. And I can go around the world, and people living near the coast will have to do a lot about it. Some people will just have to move en bloc somewhere else. And where do they go to? I met somebody from Papua New Guinea not long ago. He was telling me about an island just off Papua New Guinea, where 200 or 300 people live. They have been farming around the edges of the island and doing very well, but all of a sudden, the sea had now risen sufficiently. It was bringing salt in and bringing more water in, storm surges, that they could no longer grow food on that island. They were getting food sent in by boat to keep them going. They had appealed to the United Nations to be moved somewhere else some years ago, and the United Nations had not even answered their request. That's just 200 people. But there are lots of them like that in the islands in the Indian and Pacific Oceans. Big problem with sea level rise. A more intense hydrological cycle. If you project how the precipitation will change this century, towards the end of the century it's likely to change a bit like this diagram. The blue areas are wetter areas by about 20%. The red areas are dry areas by up to 20%. The blank areas are regions, the white areas are regions where we don't have enough data to know, like Central Africa. And the stippled regions are the regions where the models agree rather well in that result. Those are very big changes in precipitation. How does that occur? In a warmer world, you get more evaporation from the oceans, more water vapour in the atmosphere, and that means more rainfall on average. And that's happening in the world now. You can see that increase. But something else happens when you put water vapour in the atmosphere. When the water vapour condenses to form clouds, latent heat is released, and that is the largest single source of energy for the atmosphere's circulation. So you get a more intense circulation. And simply put, that means that your rain will tend to come down in more intense storms, so you get more floods. It also incidentally means, because of the more intense circulation, that you're going to get increased dry air, and drier areas, which associated with the warmer surface, will tend to bring more droughts. Now, droughts and floods are the most serious disasters we know. They cause more deaths, more misery, more economic loss on average than any other disasters. So more of them is very bad news, not only for us in the UK, in this part of the world, but also particularly in the developing world. Just let me mention droughts. This is almost the most frightening statistic I know about climate change. The work was done at this end in the Met Office, looking at the likelihood of droughts, modelling droughts this century, comparing their modelling over the last 20 or 30 years, of seeing whether they're getting the right sort of answers. Extreme drought is defined rather precisely. If you take the usable land area of the world now, about 2% of that area at any one time is under extreme drought. 20 years ago it was 1%. By 2050 it's likely to be 10 or 12%. And by 2100, if we do nothing about climate change, it's likely to be more like 30%. Now just imagine the impact of that on people who are subsistence farming at the moment. And where do those people go? Hundreds of millions of them. So there's just a list of the sort of impacts we're likely to get to this century. I mentioned we put Greenland in the middle. Greenland is probably going to start to melt down fairly soon. In other words, the ablation around the edges, it will win above the increased snowfall in the centre of the ice cap. How long that will take to melt down, we don't know, but the likelihood is it's going to be thousands of years. But there's 7 metres of sea level rise in Greenland. So even if it took 1,000 years, you've still got 70 centimetres a year, century to worry about. And it's not just Greenland, West Antarctic ice sheet also has some instability about it, which we're trying to learn about, and we can't say too much about it at the moment, except that there is a danger that really serious things will happen there also. And I've been mentioning people, of course, so far, but there's also loss of millions of species because ecosystems cannot adapt to the new climate. How sure we're about it, I could say a great deal about the IPCC. I was privileged to be chairman of the scientific working group for 3 reports. This is the page of the science part of the report for the year 2007, last year. You can go to that website, you can actually download all those reports if you have the patience and the paper and the ink. And do some of that, because there's so much nonsense talked about the IPCC. I imagine Jim will talk about this in a minute. Jim McCarthy will talk a bit about this in a minute. But people who've never seen an IPCC report write books about it. And because they quote all the rubbish that's on the internet that you can find. So it was a wonderful, it is the most thoroughly researched, well-balanced, thorough discussion of a scientific topic that's ever been done by the world scientific community. I just noticed the bottom of that slide, the Academies of Science for all the G8 countries in 2005 wrote a letter to the G8 meeting and said, please will you respond to climate change? It's a very serious issue. And incidentally, read the IPCC reports. Now, those academies don't normally get together over anything. It's very rare that they do that, or comparatively rare. And for them these are the top scientists in the world, of the G8 countries, including India, China and Brazil. And it's remarkable that they did that, and they've done it again this year too, written to the next G8 meeting in Japan. And if you say, do the scientists in the world really believe in this, just look at that, because these are the top scientists in the top countries of the world. Now, what's been done about it? A very important statement is in the objective of the Climate Convention of 1992. It says that we must do something about climate change. Then they said we don't know all the science, of course, but we know enough to know that we have to do something. And they say we must stabilise the concentration of greenhouse gases, especially carbon dioxide, at a level to be chosen that's got to prevent dangerous anthropogenic interference with the climate system, allow ecosystems to adapt naturally, to ensure food production isn't threatened, and to enable economic development to proceed in a sustainable manner. In other words, it's a balance between all the pressures on us to tackle this problem of stabilising greenhouse gases. And it can't be a perfect balance, of course, because we can't actually turn the clock back with the climate and go back to the climate we had 200 years ago. That's just not possible at any reasonable time. Nevertheless, we can do something about the future. And I present that to you as a working definition of a sustainable climate. It is the one working definition that every nation in the world has agreed to, including signed, of course, by President Bush I for the United States. So there is no getting away from that definition. So what sort of stabilisation target? I could go into a great deal about a discussion about this, but in 1996, the European Union Council said we should try and stop the global average temperature rise being greater than 2 degrees above the pre-industrial. That implies a carbon dioxide concentration of less than 450 parts per million. It's now over 380 parts per million, so that's not very much rise that we can have over this in the future. And it implies that those emissions have to be reduced by 60 to 80% globally that is, not just by the UK or by the US or anybody, globally by 2050. And the cost of doing that is studied in the Stern report and by the IPCC. The cost of that is certainly less than 5% of the world GDP, or less than 2 years economic growth in 50 years, 40 years. That's not a big amount. The International Energy Agency has been studying this, and studying this quite hard now. The IEA joins together world government energy ministers, or the government energy ministers from OECD countries, but India and China and so on also come along. They're the top energy body in the world. They publish a report every year called the World Energy Outlook, which projects the energy industries for the next 30 years. It is the Bible of the energy industry, so it's a very powerful body. And they're beginning to look at this issue very seriously. I went to a meeting in April with 70 energy experts under the IEA talking about this, and they said, we're going to work out what we have to do to get down to 2 degrees and 450 parts per million. And there was no dissension from them wanting to do that, amongst other things too, which I thought was most encouraging. They were not political people, but many of them were policy people. So these are the people who are advising politicians, if only the politicians would listen. And that's the sort of thing we have to do to get away from that growth. It's growing by 3% a year at the moment. We've got to get away from that growth and get it down by 2030 from 42 gigatons of carbon dioxide a year to 23, and then by 2050, much to about half that amount. Now, you're going to hear later in the day from Professor Ian Arbor about this, so I'm not going to say anything about it except to give you a trailer to say that we have to do things like this: halving energy use in all buildings, carbon capture and storage in all coal-fired power stations, at least by 2030, and much before, preferably, carbon-free electricity for everybody by 2030, and the progression in car technology from hybrids and fuel cells to carbon-free hydrogen. Very major changes in the way energy is produced, energy is used. The IEA say we have to spend $22 trillion in energy investment on this issue by then, and that is equivalent to 1% of world income by then. And that's not a lot when you consider all the other things we spend our money on, and when you consider the enormous advantage of changing the climate change growth, and also changing lots of other things in the process that will all be terribly good to us, for us. Now, supposing you're in an international meeting to talk about how you're going to share these emissions out. And diagram number 1 on the screen is this diagram, like the meeting at Bali last year. The per capita emissions across the world. So going on the left, you've got the United States and Canada with over 25 tons of carbon dioxide equivalent per capita. On the right-hand side, you have Southern Asia, India, with about 2 or 3 tons of carbon dioxide equivalent per capita. An enormous difference between the developed world, the Annex 1 world, on the left-hand side, with a population of 20%, and with 4 times the average emissions of the developing world, which is 80% of the world's population. So that's the debate that's got to occur between now and December 2009 to say how that is going to be shared out in a really fair way and really set the world on a path which will make sure that the IEA projection is coming about. So that's a major change for them. And there's a tremendous moral imperative attached to that. Growth and wealth in the rich world from cheap coal and oil and gas has been going on for 200 years. We didn't realise the damage we were causing, especially to poor countries. So the imperative is for rich countries to reduce their carbon emissions and to share their wealth and skills with poor countries to enable them to develop sustainably. And we all have to face that issue. Are we good at sharing? We all have to share, learn to share, and not to be so greedy. We share well in our families, we share well in our communities, we share well in our nations with national social programs. Do we share well internationally? No. We give aid to other countries, but if you add aid and trade together, the overwhelming flow of wealth is from the poor to the rich. Now that is, just imagine what Amos or Isaiah would have to say about that if they were campaigning in Parliament Square. Just imagine those Old Testament figures really telling us how to behave. Tear Fund is a Christian aid agency, and they've just started a campaign called My Global Impact, which is about sharing your footprint of emissions with the developing world. Working out your footprint and seeing how much it is above the average and paying into a fund for what you are doing above the average to help developing countries develop sustainably. Look at that website and let me urge you to take that campaign seriously and see if you can't fit in to doing something yourself personally about it. That's to a statement last week in Aberystwyth University, the Institute of Grassland and Environmental Research. There is sharing skills. In the back of that diagram, you've got a biogas to hydrogen plant, a prototype, which will be very valuable in the third world. And in the front, you have people who come from a variety of countries, from Europe on your left to India, Pakistan, Taiwan, and Bolivia. So there is some real sharing of resources, which is occurring in a university in this country, and the potential for getting together, not in a patronising way, but in a very much working together way, sharing our wealth and our skills with the developing world is a very important thing to do. I often use this quotation in lectures of this kind because I think it's a very telling quotation. It was 300 years ago or so, Edmund Burke, the British parliamentarian, lots of good quotes in the speeches he made. Nobody made a greater mistake than he who done nothing because he does so little. Now, many people say, I've heard top people in Whitehall say it, we're only a small country, 2% of the world's carbon dioxide emissions, why do we bother? You may say, well, I'm only a small person, I'm one in 6.5 billion. What can I do to help this? Everybody has to do something, and nobody can opt out. Otherwise, the problem is not solved. Those of you who are philosophers and know about the prisoner's dilemma will know the sort of thing I'm talking about. People often say to me, you're wasting your time talking in this way because the politicians will never agree. Why don't you go and do something else? And are you optimistic? And I say I'm optimistic for 3 reasons. And the first is that I've seen the commitment of the world scientific community, a remarkable commitment under the discipline of science and under the honesty that goes with that. We've set about saying what we know, what we know reasonably well, and explaining that, and also explaining what we don't know, and putting in a lot about uncertainty, so much so that many people think because we use the uncertainty word rather often, we're really very uncertain, but we're not uncertain. We just want to tell you how certain we are. And that's been a remarkable commitment. People from all over the world, different ideologies, different religions, different backgrounds, different personal agendas come together and will write a strong document saying what they believe and get consensus about it. I know the next necessary technology is available. And you'll hear more about that later in the day. And I also believe that God is committed to his creation. So you say, why bring God into it? I believe that as human beings, in order to be fulfilled, we mustn't just follow economic growth at all costs. We must not follow greedy agendas, because we're not being human beings when we behave in that way. We desperately need to have moral and spiritual challenges. Otherwise, how can we fulfill our task as human beings? There we are on this spaceship, and we need to have moral and spiritual challenges. Over 10 years ago now, Sir Crispin Tickell, who's often lectured on climate change, a diplomat, who was very interested in climate change in the 1970s and wrote a book about it, although he's not a scientist, and he's been campaigning in various ways ever since. He said, mostly we know what to do, but lack the will to do it. And he's not a particularly religious person. But that's a strong statement to make, and it's a very terribly true statement. We know what to do, but we lack the will to do it. So if you ask the question, what are the root causes of unsustainable climate change? I've just listed 4. I could list many more of the same kind. Ignorance, we didn't know about it. And that's true, we didn't. Denial, we didn't want to know about it. And you'll hear more about that from Jim McCarthy. Procrastination, we said not now. And there are very powerful forces in the world who are trying to tell us all that we needn't do anything about it now. You'll hear something from Donald Hare about discounting the future. And that's very relevant to that particular issue. Why we've got to do something about it now? It's terribly urgent. If we don't do something about it now, it will get more out of control. And then there's the lack of will. We knew, but we didn't do. Now, if you're a religious person, you might well lump all those together in three letters. S-I-N. And you'd be right. It's a spiritual problem we're talking about. So let me finish with the most telling spiritual symbol I know. That's the cross of Jesus, surrounded by the world. Put those two together, and you're beginning to get the bones of the solution. Thank you very much.
Thank you, Sir John. That was very good timekeeping and very good use of 2 projectors simultaneously. And I hope it works next door in the overflow. It means we have a good 10 minutes for questions.
Thank you, Sir John. Calvary and Bailey. I've been challenged several times recently by people who claim to be informed about the scientific evidence, and all of them have said to me, 2 in particular, that they say the seas are not warming, they're cooling. Can you comment on that? I'm having difficulty responding because I just don't know the science myself.
Well, of course, there are big changes going on all over the world. And these are not uniform. The seas are undoubtedly warming up, on average. There's no doubt about that. But there are some areas of the sea where cooling is occurring. And there are some areas of the sea where there is no sea level rise, for instance, in parts of the Indian Ocean. The Maldives happen to sit in a place where the sea level is not rising at the moment. So there are changes. But if you take the global average, which is what we're doing when we're looking at the whole scene, the seas are warming. And there is no doubt about it. Look at the IPCC report. It's all there, in there.
Can you pass it forward 1 notch?
Yeah.
Thank you, John Gilroy here. I'd like to make one observation. I love your quotes, and one I use. I've been accused all my life as an environmentalist, I'm sure you have, of being a crank. You remember what Schumacher said? A crank. I don't mind being called a crank, because a crank is a small instrument that can create revolutions. And that, of course, was Schumacher, who wrote Small is Beautiful, and is been very instrumental in developing the world. Can I ask a more technical question to follow that? Water vapour, because again, we've just been talking about people arguing that the sea, because there's variability. With water vapour, some people say that water, in fact, is the greatest greenhouse gas of all. Is that true?
Yes.
It really is. And if there's more of it being evaporated, are we getting a vicious circle? But could that be counteracted by the whiteness of clouds a bit?
Well, water vapour is the strongest greenhouse gas.
That is.
But it's not growing because we're not putting extra water vapour in the atmosphere. Any extra we put in is very rapidly rained out by the whole system. But water vapour, as the temperature rises, water vapour also rises. So water vapour provides a positive feedback for climate change. In fact, if you have no change at all in anything else on Earth other than carbon dioxide, and you double carbon dioxide, you get about 1.25 degrees increase in global average temperature. But because of the water vapour, increase in water vapour that also occurs, that goes to about 2 degrees, actually roughly doubles, nearly doubles, because of the water vapour increase. So that's a positive feedback. And there are positive and negative feedbacks occurring within the climate system, some of which we know a lot about, others of which we know less about. Clouds has always been a problem. To know how clouds will or will not increase as the temperature goes up and as climate changes. And the uncertainty we put on the doubling of carbon dioxide, the IPCC has put on it to global temperature rise from 1.5 to 4.5 degrees. It's now 2 degrees to 4.5 degrees incidentally. It's narrowed during the last report. Has been very largely because we're not sure about whether clouds have a positive or negative feedback. In fact, the answer about clouds is they have both, because low clouds have a negative feedback and high clouds have a positive feedback. So and clouds vary all over the world. We have a lot more information about that now, so that the average feedback of clouds is not large.
Some questions at the back on the side. What we'll do, we'll take a couple more questions from here, and then we'll go to the overflow, because we've only got one microphone left.
Sir John, one of my favourite quotations, which is very close to one of yours, comes from the work of the Club of Rome, Beyond the Limits, many years ago. And they said, and I quote, "The transition to a sustainable society is technically and scientifically possible, maybe even easy," their words, "but it is psychologically and politically daunting." Now that seems to chime in with what you're saying. What are your suggestions for the way in which that massive psychological and political obstacle can be overcome?
Well, I'm a scientist, so I'm commenting in a technical way on that. On the psychological is not something I'm prepared to do very easily. But we all have to be informed. Something that's terribly important is that good information gets around the world, so that people really understand what it's about, and that somehow or other the deniers who are spreading falsehoods can somehow be marginalised. The media have a big responsibility in that, and some of us talk to the media a lot about this responsibility that they clearly have, and politicians have a strong responsibility also to spread that message very clearly. And it's changes of attitude that are really needed, and that brings you to the spiritual problem. And I see you're a person from a church, so you will know about that. And if the Christian churches could get together and could really do something in a practical way around the world and say, we are Christians, we understand this issue, we understand the moral responsibility and the spiritual demands on us, and if they got together in a way which is an order of magnitude, many orders of magnitude better than they are at the moment, then the world might listen to us as Christian people in a way they've never listened before. So let me encourage you to get Christians together on this issue.
And can we go over that side?
Actually, I am a psychotherapist and also an eco-psychologist, which is a field that is increasingly exploring humanity's relationship with nature and the difficulties we have in understanding our place as creatures within the systems of nature instead of above nature. Yeah. And when I first put my hand up, I wanted to ask you whether you would add to your 4 descriptions of ignorance, denial, procrastination and lack of will, the factor of fear, which is the psychological factor that I'm most interested in. And I think that we do need to take very seriously the degree to which, particularly in the West, people's core identity now is almost inextricably linked with their material wealth and the accumulation of material goods, which are expressions of their core being. And the fear of having to give that up is a real and terrible fear. And I think that that is something that we need to take very seriously and very gently with people, and that is one of the tensions, I think, is very present in our desire to present incredibly important information very rationally and in very large quantities without being mindful of the irrationality of being human.
Thank you. I mean, I think some people, particularly, of course, the deniers, tend to emphasise that to do something about climate change is going to kill our economies and ruin our standard of living and make life impossible. Now, all of those things are wrong, because we don't have to do anything so large that it destroys our way of life, destroys the way we do things, or reduces our enjoyment of life at all. In fact, a lot of the things we're asked to do are things that will enhance our enjoyment, enhance our well-being, and enhance our relationships with other people in the world. So we must not preach doom and gloom. I do not believe in preaching doom and gloom. I say things will be better in this world where we really take this thing seriously, and encourage people to come along with it. And in order to be better, you don't have to say, well, I can't give up my gas-guzzling car, because there are perfectly good cars that will take you around with very much less use of energy. And the whole business of trying to look after our world is something which should reduce fear rather than increase it. And perfect truth casts out fear. And truth is something which is very vital to get over to people and to get rid of all this misinformation that's spread around that makes people very frightened. Thank you.
Yes, I have two questions from next door. And the first is in relationship to the comment you made that the IPCC is not politically influenced. The question is, many commentators say it actually understates the likely impacts of climate change due to especially US influence. I was asking for your comment on that.
The question is, does the IPCC understate climate change?
Yes.
The IPCC has been very cautious in the way it's put its information over. We've tried to say things we know, and not to in any way exaggerate or hype up for the sake of trying to get the message across, because that is very counterproductive. So we have been cautious. I don't think we've been negative in that sense and doing it in an improper way, although some people have accused us of that. I think the evidence is that we've done an honest job. But the message has got stronger over the years because we've had more information, we've had better information, and we've been able to make the message stronger. We've realised some of the positive feedbacks, for instance, and been able to quantify them probably more serious than we imagined. So the message has got stronger over the years. But the messages are strong enough to make everybody say we've got to do something.
And the second question,
Thanks. Yes, the second question is, would you believe there's a technological fix to the climate change problem, or is there a need for a more fundamental change of human behavior? And if the latter, is there room for optimism that people will change their behavior?
Yes, I mean, there is a lot of technology out there which we can use, and we have to use sensibly and thoughtfully and carefully. Different technologies will apply in different places, depending on whether you're living in a hut in an African village, or whether you're living in a city in China, or whether you're living in a big city in the developed world. The technologies will be different, and they have to be appropriate. And there is no one technical fix. There is no one solution. So we must be very careful about using the word technical fix, because I think that's a dangerous statement to make. I remember right in the early days of the IPCC, a senior man in the IPCC who was running one of the other working groups said, says that he was American, he said, "Look, we in America, we will never change our way of life at all. We've just got to fix the biosphere," he said. He was a nuclear physicist. So technical fixes is a bad word to use. But I do believe that we can do things sensibly and carefully. We must do them sensibly and carefully. And by that means, we will come to a solution. But nobody must imagine that there is one solution, however hard the nuclear people or the geoengineering people, either. There are people who want to put sulfates into the stratosphere, saying, "Oh, we just got to block out the sunlight a bit." That would be disastrous for the ozone layer by doing that. We will, we try and change things in that sort of way. The world is littered with environmental disasters which have been put in the first place for good reasons. So we've got to be very careful we don't follow any of those disastrous paths.
Well, thank you very much. That's got us off to a great start.